In this video, I will show you how to do a quantile regression in R. Before you watch this video, please make sure that you have also watched quantile regression video and the quantile regression example video that I have on YouTube. So I have opened here the program in RStudio, and I have also executed it so that we can look at the results. So the first thing to do is install packages, and we will use the quantreg package. So you can do this from packages right here and install packages, or you can just delete the pound sign and run this line and then put it in the library. The next thing is to read my data, which you can download from my website, as well as this program to follow along, and then attach the data. So if we look at the data, we can look at workspace here and open up the data. Here's what we see. We have data on medical expenses, and this total expenditures would be our dependent variable. And if you notice, they're like nicely sorted in an increasing order, and they vary between 3 and a lot more. Actually, we have more observations than this. It just ends there here for the preview of the data set. Then these would be our independent variables: supplemental insurance, 0-1 variable, total number of chronic conditions, age, female, and white. These would be our independent variables for the models. So this is how we define the variables. We use cbind. This would be the dependent variable, and the independent variables would be these 5 variables. We're cbinding that in X. So when you get this program, all you have to do is put your dependent variable here, independent variable here, and then the rest of the program should run with your data, and make sure that you read your data set in there. So we can calculate some descriptive statistics here, and we see the summary here is minimum is 3 and maximum is 125,610, and we have that the average is about 7,290, and so on. And these are the summary statistics for the independent variables. The next thing to do is just run an OLS regression, and that is accomplished by LM. You put the Y and X variables here, you read in the data, and then you summarize OLS regression, and these are the estimates here. So I'm going to concentrate on this coefficient here on total, on the number of chronic conditions. So we have each additional number of chronic conditions brings $2,528 more dollars into total medical expenditures. There's only one set of coefficients. This is the OLS interpretation of coefficients. So now, how do we do quantile regression? The command for that is RQ, and then you put the dependent and independent variables, read in the data, and tau is the quantile. And I have put here 0.25, 0.5, and 0.75. But you actually can put any quantile that you want to. You may want to put 0.05 and 0.95, or you can put every 10 percentile, like 0.1, 0.2, 0.3, 0.4, the way you want it. So once we estimate, these are the results that we get. So for the quantile regression, here are the 25th percentile coefficients. And we have some warning signs here because we have some non-positive values, but you shouldn't worry about that. It will probably work just fine with your data. So here's this number that we get for the quantile regression. And the way to interpret it is we need to say at the 25th quantile for the dependent variable, we have each additional number of total chronic conditions brings only $782 more dollars in total medical expenditures. As you can see, this is a much lower value than the one that we had before. So we can say that we have actually a lower value for the low quantiles, for those that have very low expenditures. And if you want to do a confidence interval around here, you can put this plus or minus 1.96 times the standard error to get 2 times, the standard error around, to get the confidence interval. And then you can compare the OLS coefficient to this confidence interval, and you will see that actually it's outside. So we can say that this coefficient, in addition to being significantly different than 0, which is the normal significance that we use, this coefficient is also significantly different than the OLS. These two confidence intervals don't cross, and that's a good thing. That's why we're using quantile regression. Notice this coefficient here is getting larger in value, but again, the confidence interval around this coefficient does not include the OLS coefficient. So again, we have significant difference. On the other hand, this is the highest coefficient, and if you look in value, it is very similar to the OLS coefficient, and this time we don't have significant difference from the OLS coefficient because the confidence interval contains it. So here we have significant differences from the OLS for low quantiles and not a difference in the high quantiles. The next thing that you can do is you can also estimate simultaneous quantile regression, where these two equations are estimated simultaneously. And actually, one thing that you notice from the results is that we have very, very similar results. Another thing that you can do is you can also do an ANOVA and compare the coefficients from the 25th and the 75th quantile. And you can see that there are actually significant differences in the coefficients, which is a good thing and justifies our use of quantile regression. So here's the most fun part, which is plotting the data and the coefficients that we found from the quantile regression. And these are very useful for presentations. So we will estimate the quantile regression, and we will have the sequence from 0.05 to 0.95. By 0.05, we will read in the data, and we would plot the summary of this data, of the coefficients. And these are the results. I already ran the program. These are the results that we have. Very nice graphs to put in a paper as well as present. Notice this was the variable that I concentrated on the presentation, and I'm going to look and explain this one. This horizontal line that you see here is the OLS regression coefficient, and this is the confidence interval around it. So if you notice, the magnitude is exactly what we had in the OLS regression. If you don't believe me, scroll back and see the results. And these are the values and the confidence intervals around the quantile. And so notice that the OLS would always be flat in all of the estimates because it doesn't vary across quantiles. It's the quantiles that could do anything. And this is the best example of how quantile coefficient should look like in order for us to have an interesting story. So for the low quantiles, we have significant difference from the OLS. And for the high quantiles, we have significant difference above OLS. And if you remember from the results at 0.75, we don't have significant difference. That's when they cross. So this is a very nice example. And how do you find significance difference from 0? Well, look, 0 is here, and the OLS coefficient is way above 0. It doesn't include the confidence interval, doesn't include 0, therefore we have significant difference. And we also have it for the quantile regression. So this is the normal significance from 0. Now, if we note like the coefficient that we have here, this one isn't very interesting because it's not different from the OLS regression very much, except right here in the last quantiles. So we want more of these results and less of these when we have our own paper. So I hope you like this presentation. Thank you for watching.